Okay, so this is chapter 8, required questions for the material, for the periodic, النهاري, 2 4 not a lot, maybe 5 8 7 questions بيطلعوا. About the dot cross. Okay, نحن اتفقنا in the last chapter that we can write the electron configuration of any element, any atom. For example, Na11, we can write it as using the 288 method or the SPDF, right? Using 288, it will be 281, right? This is last chapter. If you don't know, you can go back and watch. Using SPDF, it's the same thing as 288, but we're just going to use S's and P's. S always takes 2, and P always takes the number of electrons minus whatever S took, right? So in the first shell, S always takes 2. With SPDF, you always put the number of the shell you're working with before the letter. Okay, so since I'm in the first shell, I write 1s. S always takes 2. There's no more electrons left in the first shell for P to take, so we move on to the second shell. 2, you open up with 2. Why do I say 2? Because I'm in the second shell, خلاص. 2, open up with S. S always takes 2. Okay. 8 minus 2 is 6, so there's 6 electrons left now to go to P. Again, I have to say 2P to tell them that I'm in the second shell. 2P, and how many go to P? 6, because 8 minus 2. Then the last one, now I'm on the third shell, so I say 3, start with S. S usually takes 2, but there's only 1 left, so I'm gonna write S1. Okay, so now اتفقنا, this is how we write the electron configuration. But now we're actually gonna draw the atom. How do you draw an atom? You start over first thing by drawing it and putting a circle around it. Na. We're going to go shell by shell. We're going to start first with 2. I'm going to draw it in red. First, I'm going to draw the 3 shells, since I know it's 3 shells. I don't want to keep on switching colors and whatever. Okay? Type. So, the first shell has 2. So you're going to take, this is how you write. Follow these steps. Please don't, you're going to think, oh, it's Habal, you're just drawing circles. But it's important for later. You start with the first one, you draw it as a circle. Okay, draw circles, not X's. I'll explain later on when you do X's, when you do circles. And you go around. I prefer to go clockwise. You can go counterclockwise, doesn't matter. So that's 2, right? Now I have 8. In the second, now I move on to the second shell. So I have 8. So start 1. I go clockwise to here, 2. I go clockwise to here, 3. I go clockwise to here, 4. Now when you go clockwise again, you're gonna go here. You're going to go back up here. So you're going to write another one. And you go clockwise again, you're going to go here. Go clockwise again, you're going to go here. Go clockwise again, you're going to go here. Khalas, I have 8. Why this is important going clockwise? It's because some people do this. 1, 2, 3, 4, 5, 6, 7, 8. That's wrong. Okay? Always go clockwise. 1, 2, 3, 4. You will always have 4 slots. 1 here, 1 here, 1 here, and 1 here. Okay? Very important. So you start 1, 2, 3, 4. Okay, I finished the rotation, so I start again. 1, 2, 3, 4. Heck, I have 8 in my second shell, so I finish the second shell. Hala, I have 1 in the last shell, and you can put it here. وين ما بدك. Okay? So for one element, this is pretty much how you draw the element. Very, very simple. What's important later on, so when I say the term, you don't get lost. This is referred to as a lone pair. Okay? Meaning it's 2 electrons like together. Yeah? That's why it's called a pair. So this is how you write the electron dot diagram for an element. How about for an ion? Because you guys know Na actually exists as Na plus, right? And you know, Na plus has 10 electrons, right? Why? Because the charge is positive. It's usually 11. You subtract by the charge, so it's 10, right? It loses 1 electron. So you can see the Walid, okay, how do I do it? How do I draw it now? So easy. You lost an electron. So you go to your Na. You just take this out. Simple as. So now you go to your Na. You go over here. draw it again. Now what? I only have two shells, 2, 8. So I just redraw the same thing. 1, 2, and then, oh wait, 1, 2, 3, 4, 1, 2, 3, 4. But we're not done. If you leave it like this, it's going to be wrong. Because when you look at this now, if someone came and looked at this and there wasn't an A, let's say it was just an atom X, okay, he's going to be lost. He's going to say, what's this? How am I going to know what this is? Because there could be millions of atoms that have this configuration, okay? So what do you have to do to show that this is an Na plus? You put a bracket around it and you just put plus. That's it, okay? If you want more information, you can go and read the notes, which I definitely advise you to do. Let's start, okay? No, let me do bonding first. Okay, for bonding, you guys know bonds can either be covalent, right? Covalent, I'm gonna write it like this, bonds. I'm gonna underline, and you guys know it can either be covalent or it can be ionic. And this is something that has been stuck with us since possibly grade 9. Ionic bonds and covalent bonds, what's the difference? It's one keyword that maybe some of you may remember. And covalent bonds share electrons, where, however, in ionic bonds, you completely transfer the electron, okay? Of course, ionic bonds, it's when you have a metal and a non-metal. It's caused by electrostatic forces, in other words, positive attracting negative and negative attracting positive. Covalent bonds only happen with two nonmetals, right? You need to know that it's sharing electrons. We have two types of covalent bonds. What are they? Three types, sorry. Obviously, the single, double, and triple. In the single bond, it's obviously one pair. In the double bond, it's two pairs. And in the triple bond, it's 3 pairs. So you're now gonna come and you're gonna ask me, Walid, how do I know what to do? So I'm gonna give you examples, so we can, I will go over them easy. I'm gonna give you Cl2, O2, and I'm gonna give you N2. Okay, Cl2 is in group 7. Okay, what's important here with the dot cross, okay, with the dot cross representation is, and it was written in the notes actually, is only write the valence shell, okay? If they require you, obviously it's better to draw all of the shells, right? But usually it's way easier to just write it like this. So chlorine, it has 35 electrons. So you're gonna go 1, 2, 3, 4. No, you don't do all that. Nahna, to make our lives easier, it's in group 7. So what we care about is the last shell, because aslan, the last shell is the only thing you're gonna need for bonding. So it's in group 7. By the way, chlorine, let me show you. It's in group 7 over here. So it has 7 electrons in its valence shell. So it looks like this, right? So in the dot representation, I'm sure you guys have seen something like this before. I'm definitely sure. Okay, it looks like this. This is the dot cross representation as a simplified version. But if in written they ask you to draw, don't draw this. But for solving questions, you're gonna see now you only draw the valence shell because you're gonna have bonding. And for bonding, I'm not gonna draw the whole atom here and the whole atom here. I don't care. That's useless. The only thing I care about is the part where they bond. And the only part that actually takes part in bonding is the last shell. So anyway, I'm talking a lot. Let me show you how to do it. Chlorine is in group 7, oxygen is in group 6, and nitrogen is in group 5. And you guys know, our whole goal for bonding is to reach 8 electrons, right? In our valence shell. That's the whole goal of bonding. Why? It wasn't mentioned in the notes or course revision, but our teacher taught us it. You should know this. Every atom here wants to be like the noble gases. The noble gases are like they're like they how can I say this? They're like the most important gases. Everybody looks up to them. They're the successful ones. They're the ones that are living their life. Everybody wants to be like a noble gas. Noble gases have 8 electrons in their valence shell. That's what everybody wants. Here, to reach 8 electrons, they have to lose. Here, to reach 8 electrons, they have to gain. Obviously, each group, you guys know, determines the number of electrons you have in your last shell. In group 1, they all lose 1 to become 8. In group 2, they all lose 2 to become 8, and so on, and so forth, and so forth. Chlorine is in group 7. It has 7 electrons, right? Obviously. Oxygen is in group 6, so it has 6 electrons. Nitrogen is in group 5, so it has 5 electrons. Why am I going over this even though many of you already know this? It's just so it's a refresh. So chlorine is going to look like this, right? Always start. You have 4. You go clockwise. 4, 5, 6, 7. So actually, I'm gonna place this one over here, okay, to make my life a bit easier. So you see, we have 3 lone pairs, right? We're doing chlorine bonding with itself, so it's gonna look like this. So no, don't do what I did here. In the exam, start 1, 2, 3, 4, 5, 6, 7. So they both have 7 electrons. Type, okay. I have 7. What do I need? I need 1 electron. I have 7. What do I need? I need 1 electron, right? So what happens is the chlorine here on the left and the chlorine on the right, they kind of take these electrons and they come together. What do I mean? I think I can select. Okay. They come together. So they go and, oh, not like this. And they come over here and come beside each other like this. And they form what is known as a covalent bond. I made a mistake here. If this was written, you're going to get this wrong. I would have gotten this wrong. Why? To distinguish one atom's electrons from the other, use one as circles and the other as x's. Okay? So I should have drawn x's here. Let me draw x's. Like this. That's a single pair. Why? Because 2 electrons are being shared. How about O2? Again, you're doing bonds. So what's the first thing you do? You draw both of the dot crosses. So O2 obviously has 6, so we're gonna go 1, 2, 3, 4, 5, and the 6th one, place it in a way that it's easy for you to draw. It doesn't matter where you place it. Really, it doesn't matter. Okay? And the other O2 again, 1, 2, 3, 4, and then you could say 5, 6. Again, this oxygen has 6 electrons, and this oxygen has 6 electrons. To become 8, they need 2 electrons. And whoa, they see 2 free electrons over here. So what do? They go and connect each other. So that way, now when they connect, oh, again, sorry, I was supposed to use x's. Sorry, I wasn't paying attention. Let me use x's. X, 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 X. Okay, so it wants 8. So what's it going to do? It sees the other oxygen. It goes all the way towards it. And it forms a connection over here. Like this. What do we have here? We have ourselves 4 electrons now being shared. 4 electrons now being shared, which means it's a what? A double bond. Okay. Finally, with N2. N2, it has group 5, so it's 5 electrons. So let's draw the electron dot cross. 1, 2, 3, 4, and the last one you can put it wherever you want. I'll put it here because it's a bit easier. Other N, I'll use X's this time. And the last one you can put wherever you want. I'll put it here so it's a bit easier for me to connect them. Okay, it has 5. To get to 8, how much does it need? 3. It sees 3 free ones over here. So what does it do? It goes towards it. So it now comes closer and closer and closer and closer. Bam. This one goes here. This one goes here. And they all form a covalent bond in the middle over here. How many electrons being shared? 1, 2, 3, 4, 5, 6. So it's a triple bond. So now, if you don't trust me, count. 2, 4, 6, 8. It has 8. 2, 4, 6, 8. Originally it has 7, but it's taking the 8th one as sharing it with the other one. Same here. 2, 6, 8, right? And 2, 4, 8. Same thing here. 2 plus 6, 8. 2 plus 6, 8. This is how covalent bonds work. So now, let's do the questions. Let's start with H2. We want, it's a bond. Okay, if they just said H, you take your time, you write the whole atom. Okay, also it's not anyway. H2, it's a compound, right? So في bonding بالموضوع. H is in group 1. I think everybody knows hydrogen only has 1 electron. Okay. You guys know hydrogen is H plus, right? It's H plus. So it loses 1, right? Here, these are all negative. Group 7 يعني Cl minus. Group 6 يعني O2 minus. Group 5 يعني N3 minus. Right? So these are all gaining. But if, by the way, you looked at group 1 elements, like lithium over here, lithium with another lithium, they're both Li plus, Li plus. So they're both gonna lose. So they will both be satisfied if it's just 1 electron, 1 electron. Right? Because these ones, group 1, 2, and 3, they're losing electrons to become like the 8 over here. I hope you understand what I'm trying to say. So these 5, 6, 7, they gain to become 8. 1, 2, 3, you won't end up with 8. You're going to end up with less than 8. They're losing because they're losing. Let me show you an example. The first and easiest one is hydrogen. Okay, hydrogen, group 1, so it's H plus. So what do you know? Since it's positive, it loses. So hydrogen here, hydrogen here. 1 electron from hydrogen here, 1 electron from the hydrogen here. That's it. Should be it. Yeah, and then circle it, obviously. My fault. Obviously, in the middle, there should be intersection between the circles, right? Very, very easy. Just like that, you see? 1, 2, 1, 2. Over here, they don't have 8, but it's satisfied. Why? Because خلاص, it's lost this electron and it obtained noble gas configuration. You don't have to have 8. You can have 0 as well. 0 as in you don't have anything left. If you try and understand what I'm trying to say. يعني. HF. Okay. H is H plus. F is in group 7. So it's F minus. You can open up the periodic table. It's over here. Fluorine. Okay. So this is going to lose 1. This is going to gain 1. Let's see. Hydrogen looks like this. Right? What does fluorine look like? Let's draw hydrogen. This is H. No, I should draw it. Yeah, okay. I'll draw it like this. Then fluorine, we're gonna draw it over here. It's in group 7, so it's gonna have what? 7. They're bonding, so I'm gonna put this circle like this. So let's draw the 7. You start up. We're doing x's. Why x's? Because it's another atom. You need to put 1 circle and 1 x. Okay? 1, 2, 3, 4, 5, 6, 7. So we have 7. To become 8, we need to gain an electron. And how do we do that? We do it by sharing with H. So in the exam, you're not going to do it like how I did now. You're going to get H. It's 1 like this. You're going to draw it. Okay? Then you're going to get F. You're going to draw it. You can say, oh, 1, 2, 3, 4, 5, 6. Don't draw it like this. Do it like I told you. 1, 2, 3, 4, 5, 6, 7. Don't do what I did now. Okay, then you can see, oh, this needs 1. This needs to gain 1, right, to become 8. And this needs to lose 1. So they can just come together like this. 1 here, 1 from here, and start sharing. This way F has 8, and H lost to get 0. And you know, the groups 1, 2, and 3 are satisfied with the 0. That's their noble gas configuration. Okay, H2S, I'm gonna go a bit quicker with these. So, the ones where you have a compound like مثلا H2O, you're gonna be like, okay, how do I connect it? Obviously, this big one, the O goes here, and the H's are connected like this. Okay, always the big parent molecule is connected to both the other two. Okay, so H2S now, you have a sulfur. Okay, sulfur is actually, I think it has 6 valence electrons. Let me double check this. It has 1, 2, 3, 4, 5. Yeah, 6. Because the charge of sulfur is 2 minus. It's something you need to memorize. It's not in the periodic table. Okay, so sulfur is S2 minus, so you know it should gain 2, which means it has 6 electrons, right? So let's draw sulfur. 1, 2, 3, 4, 5, 6. Let's draw 2 hydrogens. We're gonna draw a hydrogen over here with an X, and a hydrogen over here with an X. Okay, what do we see? What do we need to reach noble gas configuration? That's always the question you ask yourself. What do I need to reach noble gas configuration? Sulfur needs 2 electrons. Hydrogen, this one needs to lose 1. This one needs to lose 1. Immediately, this one needs 2, and these 2 are willing to share their electrons. So if this one bonds over here, it can lose it, and this sulfur will gain it, and that way this hydrogen will be satisfied, and sulfur will only need 1 more, so it can bind with this one. That way this hydrogen will lose it, and this hydrogen will be satisfied, and that means the sulfur now has gained 2 electrons, and it has obtained noble gas configuration. So let's fix it a bit. It's gonna look like this: sulfur, circle, 1, 2, 3, 4, 5. Where do I put 6? I put it here. Plus, over here we're gonna put 1 hydrogen, right? We're gonna put an X for it, and over here we're gonna put another hydrogen, put an X for it, like this. That way. Oh no, sorry. The X is supposed to be part of the sulfur as well. So hydrogen over here. So the X here and dot here. So this X, imagine it's over here. Like I should have moved it a bit to the right. Okay. So this way, hydrogen lost 1. This hydrogen lost 1. They're satisfied. Sulfur now has 8. Okay. Let me move on a bit. I'm going to go a bit faster. N is 3 minus, so it has 5 electrons, right? 1, 2, 3, 4, 5. I'm getting these numbers from the periodic table. You can check them yourself, okay? Because it's in group 5. Okay. It needs, you have 3 H's, right? 1 over here, 1 over here, and 1 over here. These need to lose 1 each, and this needs to gain 3. So like we did for sulfur, same exact thing. Okay, you're gonna draw 1 N, right? You're gonna share 3 of them. So we're gonna put, I'm gonna start 1 over here, 2, 3, 4, 5. I'm gonna put 1 hydrogen here, 1 hydrogen here, 1 hydrogen here. That way, each hydrogen is gonna give 1. Since I have 3, it's gonna give 3, and that way I'm gonna have 8 in my nitrogen. The goal is always have 8. So this circle over here, I don't know why I switched to red. Okay, you're gonna put the hydrogen here, intersect it with the nitrogen, and put the X. Put the hydrogen here, intersect it with the nitrogen, put the X. Hydrogen here, intersect, X. 8, last one. Noble gas configuration is attained. Okay, CH4, carbon. Carbon is group, I think, 6. Group 4, carbon, I think it has 4, right? Carbon, yeah, it has 4. Carbon is another one you have to memorize. Its charge isn't C4 minus, but it has 4. It has 4 electrons. It needs to gain 4. So yeah, you could say it's C4 minus. Memorize that. C4, like the explosive. So C, 1, 2, 3, 4. How many does it need? Needs 4. I have 4 hydrogens. Think of the hydrogens as just electron donors. Okay, they can give electrons for fun. So you can put it here. You can put this hydrogen over here, this hydrogen over here, and this hydrogen over here. Easy as. And you could say this is, okay, this is the carbon. This is the hydrogen, 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 hydrogen. That's what CH4 looks like. NAI, MgCl2. Honestly, I feel like we're wasting a lot of time on this, so I'm just gonna skip. Why are they using ions? So, before I move on, what we have covered so far is representing the dot cross product of covalent bonds. Ionic, we never touched it. And this is where I'm gonna touch ionic. Ionic is when you have metal and non-metal. So the first thing you're gonna ask yourself when drawing is, am I drawing a covalent or am I drawing ionic? And I'm sure you all know how to know if a bond is covalent or ionic. Covalent is both non-metals, ionic is one metal, one non-metal. طيب. For ionic, it's easier than covalent. You only need to draw the last shell, okay, as usual, and there's no bonding, okay, because it's transfer. Okay, let me use the example NaCl. This is an obvious ionic bond, right? In ionic bonds, you have ions. So the first thing you do is separate it, know what your ions are. Na plus, how does it look like? It has an outer shell of 0, right? You can tell me, Walid, how do you know? Always, the cation is going to have an outer shell of 0, okay? Because it lost electrons. The cation, the positive one, is always losing, so it's always going to have an outer shell empty like this. So you're going to draw an outer shell that's empty. And you're going to put, remember, always with ions, you put the charge outside. Type. And then you're going to draw Cl. Type Cl is Cl minus, right? Cl usually has what? This is group 1, by the way. This is group 7. Group 1 has 1 and comes Na plus, so it loses. Cl minus is group 7. So originally it has how many electrons? 7. So 1, 2, 3, 4, 5, 6, 7. بس هلا it's Cl minus. What does that mean? It gained another electron. So you put this minus and you put that new electron. Obviously you draw it as an X. That's it. That's it. Not a single bond drawn. So that's why for NaI, that's exactly what they did. You write down the ions. Na plus has 0 outer shell. Cl minus has 7 originally from it, because it's group 7. And it's minus, that means it gained a new electron. So you just draw 7 dots and 1 cross. Same thing goes with NaI, because it's the same, I is in the same group as Cl. Let's try MgCl2. Maybe some may get confused because it's more than one. MgCl2. Mg becomes Mg2 plus. Cl becomes Cl minus. Mg2 plus. As usual, the cation always, it has an empty outer shell, and you put the charge outside. Cl, we have 2 Cls, so you're going to draw one here, one here. We're going to draw the outer shell. Cl is what group? 7. So that means you're going to draw 7 original electrons. 5, 6, 7. Charge outside, بعدين بنكتب charge. And this Cl also originally has 7. 5, 6, 7. Okay, perfect. It's Cl minus. So what does that mean? It became 8, so it gained an electron. So you're going to put an X here and an X here. And now since we gained, we put our charge outside. That's it. The cation will always have an empty shell. The anion will always have a full shell. Okay, but what you need to know is how many of those in the shell are original electrons from the Cl, and how many are new. Okay, هيك نكون finish question 2. It's uncommon to see ionic bonds, but you should know it definitely and check if you need it. Okay, ClCl we did it. One thing I want to touch on is CH3OH. When you see a compound like this, we're going to do it more in detail, but kind of split it up if it's big. Okay, CH3OH, you can think of it as CH3, the C here, and then H, 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 and then it continues on to OH. Forget these lines, that's later. So think of it like that, and then you have an oxygen here that gives 2 and a hydrogen. Okay, always start here and then continue on. And you can see how they drew it. خلاص, I know at this point I think I'm done explaining drawing. Let's continue. Define a dative covalent bond. Dative covalent bonds are covalent bonds that come from the same atom. Like the electrons come from the same atom. One example is, the famous example is NH4 plus. Okay? Okay, so how dative bonds work. To explain, you can memorize it. It's a good question, so I think it's gonna come. But how it works is you have NH3. Okay, NH3 looks something like this. I'll draw it very fast. Okay, you have X here, X here, X here. You have H, you have this big circle over here. This is NH3, right? Type. We know the ion NH4 plus. You can say, okay, why on earth would you want to add another hydrogen if everything here is following the noble gas configuration? Nitrogen has 8, all these hydrogens have 8, are in noble gas configuration. Well, why? That's a good question. It's a very good point. But let's say hydrogen wanted to come along over here. Okay, hydrogen coming with its 1 electron. It's coming and saying, yo, I want to bond with you. Okay, type. It wants to bond. The nitrogen goes, it's like, okay, the nitrogen, he's like, okay, you want to bond with me? Okay, that's a small problem. I don't have any more free electrons, right? So that's the problem. So it goes and it's like, you know what? I'm gonna open up my lone pair. Okay, the lone pair, it's gonna open it up. Okay, wait, my bad. I made a mistake over here saying that the hydrogen has an electron. The whole point of dative bonds is when you attract an ion. Okay, so this NH3, it's attracting this H plus. Okay, this H plus comes, it wants to bond with the NH3. The thing is with H plus, it lost an electron, and you guys know hydrogen only has 1 electron. So now the H plus actually has 0 electrons, right? So it's looking for something to bond, so it goes quickly to the NH3, and the NH3, it sees the H plus, it has 0 electrons, it wants to help it out, right? So it needs to give the H plus electrons to satisfy its rule, right? And hydrogen needs 2 electrons, right? Like this, like over here. See, I'll have some people call 0, some people call 2. So it needs 2 electrons. For what the nitrogen does is it takes the lone pair, takes these 2, and it sends them to the hydrogen, and the NH4 is gonna look like this. You have these ones are normal, dot cross, but for the 4th hydrogen, it's gonna be dot, because they both came from the nitrogen. That's it. Examples of coordinate bonding or dative bonding are given over here in the notes. If you want to memorize them, you can go ahead over here. These 3: NH4 plus, hydronium, and NH3BF3. Okay, moving on, because I feel we took way too long on drawing and stuff, but it's something you need to learn, and خلاص, when you learn it, خلاص, you're good. عندنا هلا 4 2 4 6 2 9. Draw the dot cross diagram for O2, C2H4 and N2. So O2 and N2, I already drew them, so I'm gonna skip this. You can go back in the video. We drew them over here, right? So we can skip this easily. Maybe what they want is C2H4. So we're gonna do C2H4 since it's the only one like we didn't do. And this is where they're talking about double bonds or triple bonds or whatever. C2H4. When you have something like this, think of the big molecule and the small molecule. Obviously, hydrogen is a small molecule, so carbon are the big molecules. Usually, big molecules, I think here they're not bound together. But sorry, my bad. The big molecules are the ones that accommodate the other smaller ones. So you're gonna have these two carbons, hey, they're beside each other. You guys know carbons have 4 electrons, right? So we're gonna start 1, 2, 3, 4. The other one, 1, 2, 3, 4. Hello, you have 4 hydrogens. 1 here, 1 here, 1 here, 1 here. Again, you're gonna say, okay, how does this guy know? He probably just looked at the answer. It's kind of common sense. Like, be organized. You know, you have 2 carbons in the middle. Organized. No, you have 4 hydrogens. Put them like this: 1, 2, 3, 4. You know, like geometry. You know, make it like it's a rectangle. It wouldn't make sense if you put the hydrogen here, another hydrogen here, another hydrogen here. It wouldn't make sense. You know, space them out evenly. Anyway, these hydrogens each have 1 electron. So we're gonna put 1 here, 1 here, 1 here, 1 here. Okay, I'll put it here so you can't see it. Okay. Type. Obviously, we're gonna bond. This carbon needs 4. It has 4, so it needs 4. 1, 2, and it can take. Wait. C2. Oh. I think. Why am I 2? Oh, yeah, see. I don't know why I bugged. I didn't see this. So it takes 1 from the hydrogen, 1 from the hydrogen here. Okay, so it needs now 2 more, right? It's gonna take 1 from the carbon here, but you still need 1 more. So you can look at this carbon, or this electron over here. Since I need 1 more, this electron I'm actually gonna send it. I'm gonna send it over here, and I'm gonna place it and share it with the other carbon as well. Okay. Same thing goes here with the other carbon on the right. I have 1, 2, 3, 4, 5, 6, 7. So this one over here, I need to send it over here to the left, right? So it participates in bonding with the other carbon. These are things that you will learn with practice. Looking at structures, memorizing structures. Don't memorize, try and understand. It's something you learn with practice. This way now you have 4 in the middle. So that means there's a double bond here. These are all single bonds. This should be over here. Sorry. Okay. This should be over here as well. It should be part of both of the atoms. It should be over here. And this one like this. Obviously the X should be over here, in between both. It's by accident. So it's something, I'll show you the actual diagram because my diagram is kind of bad. You start أول شيء with the carbons. 1 carbon, 1 carbon. 4 electrons, right? Distribute the electrons to both hydrogens, and you're going to realize that if you only use 1 electron to distribute to the carbon, it won't work. Also, another way is always when bonding, carbon has 1, 2, 3, 4. When bonding, every electron is going to be used up. Always know that. Every electron is going to be used up. Except for when you have a lone pair. But carbon has 4. It doesn't have any lone pairs. مستحيل. Nitrogen مثلا 1, 2, 3, 4, 5. It has a lone pair up here. Obviously, it's used if you're going to use dative bonding, but that's a special case. Other than dative bonding, you're not going to use that lone pair in bonding. Okay? So, anytime you have these single floating electrons, the free ones, they will always take part in the bonding process. Okay? So, it's going to be wrong if you kept the carbon, this one electron on the left of the carbon, if you kept it alone, it needs to bond with something. Okay. Okay, draw the electron dot diagram for carbon dioxide. What is the shape? Does it have polar bonds? Is it a polar molecule? This is where I'm gonna start with the electron diagram, and then polar وشايب وهيدي we're gonna come to it later. We're gonna do first, the shapes wasn't really mentioned in the notes. What was this? The shape wasn't really mentioned in the notes, but where am I? I'm gonna go over it for carbon dioxide because it was in the question. So obviously carbon dioxide, the big one is carbon, so we can start with carbon. It has 1, 2, 3, 4. Then you have oxygen over here, which has 6, right? So you have these two floating pairs, and this one over here, 3, 4, and then I'm gonna do it 5, 6, like this. So that way these two are free, these two are free. So this carbon needs 4, so it can take 2 from oxygen here, 2 from oxygen here. So I should have drawn this as x's, my bad. Over here, x, 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 x. So these two x's can go here. That's 2 electrons, so now it just needs 2 more, and these two can go here. So it's gonna look like this, right? 1, 2, 3, 4. You have the oxygen over here. The x goes here. 2 x's, right? So this one goes here. This one. Wait. I'm drawing without explaining. Sorry. So they're gonna bond, right? You have these 2 x's are gonna bond with 2 over here. One of this, one of this. This x will bond with 1 here and 1 here, right? Simple as. So carbon, 2 are gonna go here, right? And 2 are gonna go here. Now, the oxygen, like we said, 1 is gonna go here, 1 is gonna go here, and oxygen, this one over here, one's gonna go here, one's gonna go here, and then fill out the rest over here and circle. This way, you have 8 in all of them. What is the shape? Obviously, it's linear. If you want to look at all the shapes, up here, you have linear, trigonal, planar, tetrahedral, bent or V-shaped, trigonal pyramid, ما بعرف شو. But this is over here. It's obvious it's linear. Okay, أنا ما في شك في الموضوع. The shapes aren't required for us. Now, does it have polar bonds? Know that the carbon dioxide is linear because they asked us it was required. Does it have polar bonds? Is it a polar molecule? This is a concept new in chemistry. Now, this is actually when we start to dive deep into newer topics. Bonds can be polar or non-polar. I'm gonna write it like this: bonds, covalent bonds, right? They can be polar or non-polar. This comes from the concept called electronegativity. Okay, electronegativity, it's from Allah, okay, from God. He created some atoms with higher electronegativity than others. That's just how it works. Fluorine, for example, is the most electronegative. You can say, Walid, okay, what's the point? What also is electronegativity? Electronegativity is an ability an atom has, or an element has, to attract electrons. Fluorine is the most electronegative. So that means it has the best ability to attract electrons from around it. Okay? When a bond is polar, it means you have 2 different elements. Non-polar is when it's the same element. I'll give you an example. Polar Polar bonds create a slight, I'll come to that. For example, you have CO2 and here you have O2. This is something you need to know. Polar bonds, due to the difference in electronegativity between C and O2, there's something called polarity. Polarity means positive, negative. But the thing is with polar, you dive into two things. There's two categories for it. Dipole and net dipole equals 0. Or something like this. It's called, one second, let me see it. It's called, net dipole equals 0. Walid, what are you saying? For CO2, net dipole equals 0. But for something else like HCl, there is a difference in electronegativity, and حتى H2O. Let me show you. Or no, not H2O. Don't take my word for it. Let me show you what I mean. HCl looks like this. Okay, it looks like this. Forget about the drawing, but just look at the bond. Okay, for now. You realize how it's a nice linear shape, H and Cl. H acquires a slight positive, so we say it like this, delta positive, and chlorine is slightly negative, obviously, right? This is why we call it polar bonds, because these bonding will cause a slight positive charge and a slight negative charge. However, when net dipole equals 0, there's no slight positive, slight negative. Because look at CO2. You had O here, right? I'm not going to draw the electron. You realize how here goes to the left and here goes to the right, so they cancel out? Exactly. How do I know if it's net dipole is equal to 0? You need to see the structure. Okay? So, when net dipole equals 0, we say that it is not a polar molecule. Okay? It's not polar. Okay? But does it have polar bonds? Absolutely. But is it a polar molecule? No. When something is dipole, like HCl or hydrogen fluoride or something where, it's not repeated cycles of the same thing, that actually is dipole and it has changes in electronegativity, which causes a slight positive charge on hydrogen and a slight negative charge on Cl. By the way, this is a fun fact, just maybe you can help you remember in your exam. The water we drink is composed of hydrogen, oxygen, right? The hydrogens in water actually have a positive charge, and the oxygen in water actually has a negative charge. And you're going to be like, okay, why are you telling me this? This is actually why water sticks together and forms a continuous path and flows together. Because when you have water molecules, actually what happens is, see how this hydrogen has positive and this oxygen is negative? They attract each other. And let's say you have another one over here. You have a slightly negative charge on this oxygen, obviously slightly positive on this hydrogen, so they attract each other, and they all attract each other. And it keeps on attracting more and more and more. That's actually how water molecules clump together and form flowing. This is due to it being a polar molecule. Okay, this is the whole point of my explanation. So, in conclusion, bonds can be polar or non-polar, the covalent ones. For it to be polar, they have to be two different elements. For it to be non-polar, it has to be the same element. Moving on, a polar bond can be dipole or net dipole equals 0. For it to be dipole, there will be differences in electronegativity, and the structure is not repeated, like it doesn't cancel out. Okay, in words, you can say in the exam, it doesn't cancel out. For net dipole equals 0, for it not to be a polar molecule but have polar bonds, that means the polarities cancel out. So, for carbon dioxide, does it have polar bonds? Of course, because it's not the same element. But is it a polar molecule? No, because look at the structure of it, it cancels out. The dipoles cancel. Question 8. At room temperature, okay, arrangement and movement of particles in solid, liquid, or gas are explained by the kinetic theory. At room temperature, chlorine exists in the gas state. Give the electron dot structure of a chlorine molecule. I won't waste my time. It's very easy. Chlorine molecule, huh? Not atom, molecule. So we need two. So one here, one here. We repeated it millions and millions of times in this recording. I solved chlorine maybe 5 times. You do 6 over here. You know what? I'll do it. I'll tell you. So you have 2 chlorines, right? Chlorine has 1, 2, 3, 4, 5, 6, 7, right? But I'm gonna erase this one and put it on the left because I want to keep space for it to bond on the right. Same thing here on the right. We have 7. It needs 8, so it sees this free one here, so it bonds together, and it's gonna be like this. Don't draw the same way I'm drawing. I'm just rushing it a bit. Use the rule I told you, go clockwise together, huh? Okay, heck, and that's it. Okay, very easy. By the way, put the electrons on the edge, huh? Don't put it like floating. Put it on the edge of the barrier. Okay, compare the movement and arrangement of chlorine molecules in the solid state to the gas state. Obviously, there will be very many differences. They said what compare the movement and the arrangement. أول شيء, the movement in a solid phase, of course, it's a fixed position. In a gas phase, it's moving. They said arrangement, in other words, you can see pattern. Obviously, in a solid, it's regular or crystal lattice. In gas form, it's random. You guys know the pattern of a gas, it's random. And then you could say arrangement is the pattern and the distance. In the solid, they're very close together. In gas, they're far apart, spread out. So, do I see this coming in the written part? Absolutely. It looks like a nice question that can come in the written reading. The pressure inside a sealed container containing chlorine gas increases with temperature. Use the kinetic theory to explain why the pressure of a gas, what's the relation between the pressure of gas and temperature. Obviously, when temperature increases, particles will have more energy and their kinetic energy will increase, right? So as a result, they're going to move faster, they're going to collide more with the walls, and thus you're going to have more pressure. This is grade 10 chemistry. The following table provides the rate of diffusion for chlorine and hydrogen. Why does hydrogen chloride, HCl, diffuse faster? Why does it have a higher rate than chlorine? Obviously, why would it, yani? Because it's lighter. But in the, here, because it's lighter, because hydrogen chloride is lighter. Mr means molar mass. Therefore, hydrogen chloride is faster than chlorine molecules. Realize here how they said molecules, not atoms. Huh? Don't mix up. Chlorine molecules is Cl2, and its molar mass is 76. Okay? No, 71, not 76. Because some people will mix up. They think that chlorine molecule, when they think that the chlorine that we're using here is 35.5, and hydrogen chloride is 36.5. For they see this, they get confused. But no, we're talking about chlorine molecules here because we're talking about the gas chlorine. So it's Cl2 and its molar mass is 71. Okay. If temperature is increased, both gases diffuse faster, obviously because average kinetic energy is directly proportional to temperature, right? So as temperature increases, the molecules will move faster. That's it. Why does it diffuse faster when there's high temperature? Because as temperature increases, they have more kinetic energy, so the molecules move faster. Compare the rate of diffusion of carbon dioxide gas to that of chlorine and that of hydrogen chloride. Very easy. Carbon dioxide gas, just find the molar mass of CO2, which is 44. We know chlorine is 71 because we're talking about the molecule, and hydrogen chloride is 36.5. So obviously the fastest would be HCl, and the slowest would be chlorine gas, right? So chlorine is the slowest and hydrogen chloride is the fastest. Okay, last question. 9. Draw the dot cross diagram to show the electron arrangement in one molecule of methanol. Show the outer shell electrons only. So they give you this and they tell you draw the dot cross. So this is pretty easy. I mean, when they draw this for you, it's very easy. You know, carbon has 4 and it has 4 atoms beside it. So we're just going to put one here, one here, one here, and one here. Perfect. Hydrogen we know has 1, so we can put 1, 1, 1, 1. Right? You can see top oxygen needs 2, Walid, no? Okay, one here and one here. Perfect. Okay, so you put one here, and the hydrogen has one, so you just put one. So this X is from the oxygen, this X is from the oxygen, this circle is from the carbon, this circle is from the hydrogen. This way, it's perfect, but it's not perfect. Why? Because oxygen, you need to complete its outer shell, right? It has these two. I know I need to write it on the edge. Why did I do this for carbon? Because carbon only has 4, right? So oxygen has 6. So you drew these 2. What about the other 4? Okay, let's look at the mark scheme. Yeah, exactly like how we did it. But Sydney, like this doesn't matter putting it on the edge and whatever. But the way I did it in class, my teacher taught me, is putting them in between. Okay, if you want to be safe, just put it on the edges. It's fine. Complete the dot and cross diagram to show the electron arrangement in NF3. Use dots for nitrogen and crosses for fluorine. Show outer electrons only. Okay, nitrogen again has 5. It has 3 for sharing, right? So 1 here, 1 here, 1 here. Obviously, fluorine, you know, has 7, right? So it has only 1 for sharing. Fluorine has 7. This has 5. So this is the 5, right? It has 5 electrons, obviously, because it's group 5. So you took 3. So 2. You guys know how nitrogen looks. 1, 2, 3, 4, 5. So it has this pair, this pair, this pair. Okay. Fluorine looks like this. 1, 2, 3, 4, 5, 6, 7. It has this one free, right? So you're gonna do 1, 2, 3, 4, 5, 6, and then the 3 pair you put here. Henry, they want me to write it like this, and they put this here. They put the electrons on the boundaries. It's fine. It doesn't matter. In my opinion, it doesn't matter, but it's the way I was taught in class. We did it not on the wall. It doesn't matter, I think. Okay, and the same goes for every other fluorine, obviously. 1 being shared, and 7 others, 6 others in the atom. Same thing over here, X, and 6 others inside the atom. I know really it's hard doing this for the first time, but you need to learn with practice and practice. We're done chapter 8. Thank you so much for watching, and good luck in your exam.